Thanks everybody for coming to the CoreOS and Cold Beers Meetup. For
Cold Brews, get it right.
Cold Brews Meetup. Yeah. My name's Chris Galan. I work here at Apprenda, the office that you're sitting in. And we invited CoreOS and Quentin to actually, this is actually wrong, he's going to perform Prince songs.
Too soon.
Too soon. So without further delay, Quentin talking about Clair and container security. And he's not going to use the mic, apparently.
Oh, are you sure?
Yeah.
All right.
Hi, so my name is Quentin. I'm a software engineer at CoreOS. And today I'm going to speak to you about Clair, which is our container image security analyzer. So CoreOS is a company that dedicates itself into making the internet more secure. We have over 100 open source projects on our GitHub, such as Rocket, which is our container runtime, etcd, or key value distributed store, CoreOS, obviously, which is our minimal operating system. And we also build and create and build enterprise solutions, such as Tectonic, which is the universal solution to deploy and manage your containers over Kubernetes and the entire CoreOS stack. I personally work on Quay here in New York City, which is our container registry. To get into the subject, I'm going to tell you a little story. So this is your traditional deployment, right? So you have your operating system with your kernel, system, SSH, or whatever. And then you have a bunch of dependencies. Here we have Python, Java, Nginx, OpenSSL. And obviously, you have your applications on top of that. That looks pretty simple, right? So the ops are managing the operating system and the dependencies, and the developers manage their applications. Sounds good, right? Actually, is it like this? We all know that there are some communication issues between ops and developers, right? So some developers may want some version of Python, some other developers may want another version of Python, and it's quite difficult. Then the ops are like, how do I even run your application? I don't know how to run this. So one day, the ops are like, I cannot take it anymore. So I'm just going to adopt containers. I'm going to install a container runtime on our operating system, and you guys, developers, are going to put your application into containers, and you're going to ship your dependency with them. So it's better, right? So, but in practice, you end up running big ass container. Right? Sorry for the word. Big ass. Hold on, my French, right? So yeah, you end up with containers with hundreds of packages. Most of them are maybe useless. You don't actually know. And at the end of the day, who knows what's actually in their containers? The ops have no clue what's running in that container, and sometimes the developers don't even know themselves. Right? So if you look at the Dockerfile over there, you can tell me what is actually in the container. Myself, I probably cannot understand this question either. But there are also some spooky things out there. Who can tell me who is this ghost up there? Anyone? Alright. So this is one of the most famous vulnerabilities that came out last year. And this is affecting glibc and could lead to remote arbitrary code execution. Here is another one called Heartbleed, which came out 2 years ago. This one is affecting some implementations of TLS. And this is a bit more bloody, actually.
Sorry, can you shut this one? Are you getting a radio signal coming through the ground, I think? Yeah. Awesome.
But actually, there are way more than that. So the National Vulnerability Database lists over 76,000 vulnerabilities. Some of them became so famous that they have their own logo and names. It's like a brand. So, in one hand, you have fast-paced developers that deploy all sorts of containers, and in the other hand, you have a lot of vulnerabilities that only wait to be exploited and lead to data loss and data leak. With the rise of containerized applications and cluster managers, the way we have to do security assessment changed. Dependency management shifted from the ops team to the developers. And with Clair, we're trying to make this better. So we created Clair, which is an open source project for the analysis of vulnerabilities in containers. I guess I'm just going to, before explaining how this works, I'm just going to show you what kind of insight Clair can give you. So I'm going to do a short demo of our integration with Quay, which is our container registry. So earlier this morning, I found Nginx container image on the internet, and I thought that this image was quite interesting. You'll see why. So this is my local Quay instance. This is my Nginx repository, and I will go to the tags page, and here we can see actually our security scan report. And this says that this image has over 100 high-level vulnerabilities. Like, what? Right? So we can actually click on that page, and we have a report. It says that this image actually has almost 600 vulnerabilities, and my mind is totally blown. Right? This is just Nginx, right? And okay, so to be fair, 400 of them can be patched. So it basically means that this image is probably old and hasn't been updated for a while. If I scroll down in that page, I will see some OpenSSL vulnerabilities right here. We have that one. So we can see that you can exploit this vulnerability over the network, that this is easy to exploit, that you don't need authentication, and this can impact a lot on your confidentiality and integrity. We have a short description here about what this is actually. My screen is way too small, so we don't have all the columns that are supposed to be there. But anyway, so this vulnerability comes because we have OpenSSL in our container, and this is the version that we actually have on the container. Right? Nice thing is, Clair actually tells us which version I should upgrade to if I want to fix this vulnerability. So that means that if I rebuild my container, I will basically be able to remove this vulnerability from my container. More interestingly about this image, I'm going to scroll a bit, and you'll see something. This is why I show that image, you'll see. All right, right here. MySQL? Seriously? I just pulled that image called Nginx. This is supposed to be a web server. Why does it have a database there? And I have a variety for this as well, right? So, all right. So here's some awesome information about this variety for MySQL. I may learn more on this page actually. Here I have a breakdown of everything that Clair detected on that container. We see plenty of things like Linux, right? What does that even mean? It's like the Linux kernel in a container. Why? Why do we have this? Right, so let me find back MySQL here. So my screen is way too small, so I don't have the extra column that I wanted to show you. But for MySQL, I have 3 high variety, and on bigger screen we have a column saying that if you update MySQL, you'll basically remove every variety from it in that container. So yeah. So then, let's say I'm pretty confident with my image. I fixed most of the things that I cared about. I'm lazy. I don't know when I come back on that website or read the result again. So what I will do is actually set a notification. So I go in my settings here. I click on create notification. Right? I can tell me when everything loads up. Right. I can check packet variety bound. I can say, okay, right. So I care about medium or high variety. Let's say high. Right. And then you'll send me. You can send me a Slack notification. For Steam, will just send me like wait notification. Like, create notification. Right. So I'm just going to create a fake derivative on Clair right now, locally, using its API. Right. And now, updating my web page, and I have a notification right here telling me that there is a brand new vulnerability that affects my container. So if we go back to that page, see the report is actually updated. And I will see my spooky unicorn vulnerability right here. Right. Cool. So that was for the demo. I will try to explain Clair in 4 main points. So Clair does static analysis. Clair has been built in the context of analyzing millions of containers, and running these containers can be quite expensive. Also, running any of these containers can be unsafe, right? Because we don't trust these containers, and that maybe anything, and container escape exists. So we might have to run these containers into virtual machines, for instance, or use like some alternative stage 1 isolation mechanism, such as LKVM, but that's not great. Also, there are several dynamic analysis tools that exist in the world. They're very solid, like very, very solid, but usually they require human input and guidance. They need knowledge about your application to be run properly. And with the context of millions of containers, we obviously don't want to do this manually. Second point, for the second point, we need to add something new in the context. There are over 15 new vulnerabilities per day that are published. So what happens when there are new vulnerabilities published? Do you reanalyze every single image that we have analyzed before? Obviously, we're not going to do this. So Clair instead extract and store all the data that it can detect on container images. So, and because of the nature, the immutable nature of container images, I know that this data is going to be valid now, but also in the future. So I will be able to cross-match the information that I know about the container image with the known set of vulnerabilities right now, and tell you what's wrong with your container. But I also will be able to do it in a year with a new set of vulnerabilities updated. Okay, so more than that, Clair actually does its analysis layer-based. So for each layer that composes a container image, we will extract and store data. This means that for different images that may share the same layers, we will just be able to reuse the data we analyzed before, and we won't need to analyze again. Fourth part is about suggesting and notifying. So I think I've shown that pretty a lot in the demo. We try, so anyone who reads the security report, if he doesn't know what to do to fix that, it probably won't come again. He'll probably be like, meh, I don't know what to do, so whatever. So Clair tries to suggest people how to fix their containers. Then Clair also sends you notifications when new vulnerabilities come out and may affect your container. Right? So this basically means Clair has analyzed your container, and then in like 1 week, new vulnerabilities are published. And Clair detects that says new vulnerabilities may affect your container because you have some thing that the vulnerability affects, obviously, right? So Clair is going to tell you. This is what I've shown in the demo by creating a fake vulnerability that affects the container. Well, the fourth point, and I think this is like one of the most important points here, is that Clair has been built as a framework. It means that Okay, so because this is open source, we took the decision to make it very extensible, meaning that basically anyone could integrate their own behavior into Clair, whatever that behavior could be, no matter how this behavior could be like enterprise specific, you basically can integrate it into Clair. This is done through coding interfaces and registration pattern. So this is a simplified architecture of Clair, diagram of Clair. We have clients here that communicate to Clair using its RESTful API. And that RESTful API can either talk to content detectors in the case of an image analysis, or talk directly to the data store. We then have notifiers, which are the systems that send the notifications. We have the data store, obviously, and we have finally vulnerability updaters over there that basically communicates with external vulnerability databases to basically fetch their knowledge about vulnerabilities and store them into the Clair specific database. So everything you see in green there, so this is all this part is not sure about the colors here, but can be extended. And to extend them, you simply have to implement their interface. I'm going to discuss a bit very quickly about these interfaces. So for detectors, we have three interfaces. The first one is called data detector, and this thing allows Clair to understand different image formats. So it could be AppC, it could be Docker images, it could be OpenVZ images. Then it passes along this content to these two interfaces. This one is one of the most important ones. This is called feature detector, and that's basically what detects anything that can be inside your container. Finally, we have a namespace detector, and this is to create some context around the feature that have been detected and the vulnerabilities. I will talk a bit more about that later. We have then two pretty simple interfaces for the vulnerability updaters and the notifiers. So what the vulnerability updater interface do is simply asking external database, vulnerability database, and return a bunch of vulnerabilities there. The notifier is even simpler. It just takes a notification, a fixed notification, and sends it to a third party. And that one is, well, more complicated. This is our data store interface. So this represents all the interaction that we can do with the Clair backend. So what does Clair currently support? Well, we support basically two image formats right now, AppC, so this is Rocket, and Docker. Then it mainly supports three operating systems right now, Debian, Ubuntu, and CentOS. For the detection, it uses package managers, so TPKG and RPM. And where do we get the vulnerabilities from? It's from the distribution-specific trackers. So Debian, Ubuntu, and CentOS, Red Hat actually, maintain actively vulnerability trackers. And this is like hard work for them, right? But this is very important because actually we're able, so let's talk again about the namespaces. By namespacing the vulnerabilities to the operating system and the version of that operating system, say Ubuntu Trusty, Clair can track all the patches and the backward that can be made. So let's say, for instance, you're running Ubuntu Trusty, and you have OpenSSL 1.0, right? And a vulnerability comes in, and Clair is going to be like, well, you obviously have a vulnerability here. Then you can update, but to which version are you going to update? Right? Are you going to update to the latest version, that may be 1.1 for instance, but that may not be available. That may not be available on Ubuntu Trusty, but only available on Ubuntu Willy, for instance. You obviously don't want to upgrade your entire operating system. You just want to fix this vulnerability. And thanks to the fact that we use distribution-specific databases, we know that you can actually just upgrade to 1.0-security patch something. For the database, we currently support PostgreSQL. This is because we make extensive use of recursive queries, which make Clair very efficient. For integration, we only support webhook. Now, again, all these things can be extended. So anybody who wants to add anything that feels important can do it. This is like a framework. So we released 1.0 a couple weeks ago, and this is our current roadmap. So we would like to revisit our database implementation. So Huawei is actively working on making MySQL support. For instance, we want to improve our release distribution. Clair has been built as a tool that should be integrated into registries. So there is basically not a great user experience at this point. It's basically talking to APIs, so if people don't like APIs, they're going to be confused. Right? So we're going to address this. There is a person from Humanity who is willing to create a solid command line tool. So he has done it as an external project, and he's going to make it upstream. So we're pretty excited about this. We also want to add support for Alpine Linux, obviously, because this is a big thing. Like a lot of containers are being built with Alpine Linux right now. The only issue with that is Alpine does not have a great portable database right now. So here is a link to the discussion of us actually asking Alpine Linux to have a better database. And I think this is pretty important for basically everyone, not just for Clair, but anyone who uses Alpine Linux. Also, we want to implement several things like NPM, Python, OWASP. So yeah, and basically everything you would want to see. We are open to basically any contribution. If you want to learn more about open source distributed systems, we are hosting CoreOS Fest May 9th and 10th in Germany. There is also a satellite event in San Francisco. So we invite you to come there and join us, discuss about all the great stuff that we're working on. That's all I have for today. Thank you. Any question?
So are Clair and Quay Security Scanner two different names for the same thing?
So the Quay Security Scanner is simply an UI on top of Clair, basically.
Okay.
Right. This is powered by Clair. And then with Quay, we basically created an integration and an UI on top of it. Because Clair only have an API. So we basically translate the API to an UI with the Quay Security Scanner.
You mentioned there's work being done for NPM in Python. I'm assuming for Python, those system packages, those packages they make available. Is there, do you know if there's any other work being done for other languages, or is that something like you're waiting for someone to be like, hey, I'd love to have access to, let's say, Ruby, for example. They have vulnerabilities all the time.
Right. Right. We haven't get any requests for Ruby, for instance, or any other programming languages. We have had most requests for like Alpine, NPM, Python.
Yeah.
So this is basically why I wrote that here. This is a request that we have, but again, we are open to anything. And if Ruby has a great variance database, as you mentioned, right, then it should be super straightforward to integrate.
Yeah.
Like,
Is there like open issues stuff in there at the open source project that you could like look at as an example for what the other people will be working on? Right.
oh yeah, there are a lot of issues on the project. You may totally open one if you would like to see Ruby. It's just a couple of hours, I guess, to implement it.
Cool. I'll hold that then. Thanks.
Anyone else?
Question. So let's say, for example, I build my own container, right? And I launch it. How often do Clair update itself to know when my container is?
So the interval at which Clair updates its internal database is totally up to you. This is something you write in the config. Right? So you may say, I want Clair to fetch external vulnerability sources every hour.
So you could make a call to the Clair API from your dashboard of your way, or is that how you make it? How would you do that?
Okay. Could you like repeat your question, please, so I can make sure that we're on the same page.
For example, I push a container, right?
Uh-huh.
I push a container to my query, and then Clair in the back will tell me whether or not that container that I just built has some vulnerability, right? Now my question is, how often does Clair update itself to let me know whether or not that container has issues?
So I think there are two parts to your question. So first of all, each time you ask the Clair API, it's going to give you up-to-date data for him, right? Then, what is up-to-date data for Clair? Clair gets its variety from external database sources. So the interval at which Clair asks the external database sources is up to you. In the config, you can define, so for Quay, I believe it's 1 hour. But then again, if you want to say, please update yourself every 15 minutes, then you can just write 15 minutes in your Clair instance, and Clair will fetch new varieties every 15 minutes. Then at what pace does external source update itself? I don't know. I think it's like perpetual. Does that answer your question?
Does the current interface with Quay provide direct access to the underlying Clair API or to pull down reports and act on that?
Okay, so it does not give direct access to the Clair API, but there is an API call on Quay that lets you get the same information basically. Yeah, this is basically a subset. Any other questions? Alrighty.